All right, so welcome back to OneClass. Again, my name is Joey. I'm going to be your math teacher for this session. So what we're going through currently is we're going through a session of verifying solutions on live streams. And what we're doing here today specifically is for the next hour or so, I have about 11 questions for us to verify in kind of grade 8 to grade 9 math. So we have kind of problems in algebra 1, geometry, as well as pre-algebra as well. So we're going to look at these questions, and we're going to look at the solutions to these problems, and I'll walk you through my thinking processes, how to approach a solution, as well as we're going to verify the solution that's given and see if it's correct or incorrect. Just a little bit of myself. Again, my name is Joey. I'm currently a secondary school educator in Ontario. I'm focusing specifically on teaching chemistry and as well as math and musical down the road. So that's going to be my kind of goal there. Yeah, if you're tuning in for the first time, thank you so much for watching. Feel free to again wave hi or ask any questions during the stream on the stream chat, and I'll hopefully be able to, if time permits, answer your question as well. And I'll try to gear towards the questions that you ask as well. So without further ado, let's get started on these problems for today. So we have our first question here. It's asking us, how do you simplify the square root of 72? So let's see here. So simplify square root of 72. Now there's two ways to kind of approach this problem. The first way is to kind of use square root of 72, sorry. You have two ways to think of this problem. You can think of this problem as, in blue, as kind of approaching it using simplified radical form, where you're kind of taking the prime factors and you're kind of breaking down the 72 to basically an integer or a whole number and its square root. So that's some kind of simplified radical form. It kind of uses this concept of prime factors. And then we simplify using prime factors, or you can think of this question as, I believe the solution is doing. Here is the kind of the method as long division. So you can approach this using long division. And instead of giving you, and this would give you, this would give you actually, your answer here would give you an integer. So basically a whole number plus a radical. So it simplifies the radical into a whole number and radical. And long division, basically long division here, it's a special kind of long division using squares. And it would give you, this would give you a approximate decimal value. So there's two ways to go about this question, and it doesn't really specify which one to go over. So let me do the first one, because then they haven't actually they didn't really do the first one in the solution here. They only did the long division method here. So let me do number one here. Let me show you what simplified radical form means. So this is simplified radical form using prime factors, and our answer here should be integer plus a radical, or even just an integer. Let me include that, or just an integer. So let's use simplified radical form, and then I'll walk over the solution for long division here. So in simplified radical form, I would have to write our problem here, which is square root of 72, right? So we have square root of 72. It's asking simplifying the square root of 72. So here, this is the square root of 72. And what we're gonna do is we're gonna take some prime factors. So when we talk about prime factors, we are trying to break this number down, 72, into its kind of basic blocks. So I look at 72 here, and I know it's an even number, so I know it's divisible by 2, right? So I can say that I can divide this 72 by root 2, or dividing 72 by root 2 here, and then I'm going to basically multiply it by whatever 72 divided by 2 is. So I'm kind of working backwards here. Now 72 divided by 2 is indeed 36, so I would have the square root of 36, like so. And what we could do now is we can actually finish the problem here. And this solution is done because we actually know the square root of 36 here. We know the square root of 36 here is 6, right? And how do we know that? Well, we know that because we know that 6 squared here equals 36. So therefore, the square root of 36 would equal 6, right? Again, the square root and the square cancel out here, right? So you would get the square root of 36 equals 6. So we know that 6 times 6 equals 36. So therefore, our answer here is root 2 times 6. Or if I were to rewrite this, I would say, I would place the integer first. So I would say 6 root 2. And this here is our exact value, or the simplified radical form of root 72 here. So this here is number 1, and this here would be our simplified radical form. So it depends on how this question is being asked. It's asking us how do you simplify, or how do you refine the decimal here. So this would be the simplified radical form. So let me say, I'll write my answer here. I can say therefore root 72, or 6 root 2, sorry. 6 root 2 is the simplified radical form of root 72. And that here will be our answer here. If we want to do number 2 though, if we want to do the long division here, I'll walk you through the solution here, just for the sake of time here. So you're basically doing a lot, like, don't worry about these, you can read this on your own, but if I were to look at the math here, it's basically doing a long division type of thing. So I have 72 as my dividend and 8 as my divisor. I'm thinking of what number, or sorry, I don't have 8 here. First, I have nothing first. I have basically just the divisor here with 72. I'm thinking of what squared number, which number squared would be closest to 72 without going over. So it's kind of like division, but you're not given our divisor and our quotient immediately. So we have to think of them as squares. So 72 here, the closest squared number would be 8, right? 8 squared here is 64. So they subtracted 72 by 64 here to get 8. And then what they're doing here, once you get 8 here and 8 here, what you're going to do is you're going to double this quotient here. So 8 becomes 16, and this here becomes your new divisor. Now you're going to have 16, and then what you're going to do is you're going to bring down 2 zeros here. You're going to add 2 zeros to 8 to make it 800, and then you have 1 6, and basically this digit is not found yet. You don't know that this is a 4 yet, and you want to know what number would you put into the into the quotient and the divisor to make the closest number to 800. So you basically try 161 times 1, 162 times 2, 163 times 3, and you know that 164 times 4 here gives you 656, and this would be the closest number to 800 without going over. Now, we have 164 times 4, which gives us 656, and then we subtract 800 by 656 to give you 144. Again, we double our quotient, right? So we double our 4 here to get 8. So our next value here is 168, and then I'm gonna leave this next digit here blank. So I have 168, 8, or 168, and then a blank here, and then again I add 2 zeros into the difference here to get this is 14,400, and I'm thinking of a value to put into here. So it's 1681 times 1, 1682 times 2, and so on and so forth. And the closest value to 14,400 is indeed 1688 times 8, which would give you 13,504 here. And I subtract that to get 896, and you can keep doing this process till you get more decimal places. But 8.48 here is the we kind of basically stop at 2 decimal places. So this solution here is correct, or you could do 6 root 2 here, and this here would give you also, if you did the if you put this into your calculator, this is also approximately 8.48 here. So this solution here is correct. And you can say it's plus or minus if you really want to be really specific here, but this solution here is correct. So 6 root 2, it's either 6 root 2 or this long division solution here. So solution is correct. And then I'll say if placed in simplified radical form, solution is 6, and then I'll say square root 2. And then I'll just write the little work here. I'll show my work here. Equals, this would equal square root 2 times square root 36, which equals 6 square root 2. Okay, so see, our solution is correct, indeed correct here.